Wastewater costs are often a major portion of the total cost of using water. There are two main components which determine the cost added by wastewater. The first sewer charge depends on the amount of wastewater a facility produces. The second component of wastewater is surcharges related to biochemical oxygen demand, suspended solids, fat, oil, and grease, and pH. First, I will talk about sewer charges. This cost depends on how much water is disposed of by a facility. Utility providers bill under the assumption that all water that enters a facility leaves as wastewater through the sewer system. However, it is possible that processes have water that leaves in a product through evaporation or otherwise does not go to the sewer. Depending on how much water is being consumed in a process, it might be economical to install a deduct meter. A deduct meter measures water that will not be sent out as wastewater. This water ultimately gets deducted from the influent water to get an accurate measurement of wastewater. There is usually a cost associated with adding a deduct meter, so it is only cost-effective to add one when there is a significant amount of water not leaving as wastewater. Some examples of water leaving through streams other than the sewer are landscape irrigation, water used in products such as ice, canned goods, or beverages that get shipped off-site, and water lost through evaporation, such as through a cooling tower. This will ensure that the sewer charges accurately reflect the volume of water being sent through the sewer to be treated. If the wastewater strength is high, a facility might incur additional charges to cover the cost of treatment. In many communities, the wastewater utility will collect effluent wastewater samples from a manhole outside the facility. The samples are tested for key wastewater parameters, which sometimes include biochemical oxygen demand, suspended solids, pH, and fats, oil, and grease. If those parameters are significantly higher than typical residential wastewater, surcharges will be added to the bill. Biochemical oxygen demand, or BOD, is a measure of organic material that uses up oxygen in water. Different processes can add different amounts of BOD to wastewater. For example, at a slaughterhouse, rinsing out intestines would generally add a pretty high amount of BOD to the wastewater because of the organic material being washed down the drain. Product loss, such as pieces of dough, chunks of meat, or cuttings of fruit that are washed away as wastewater, can be a large contributor to BOD levels in wastewater. In many cases, if these materials are separately captured, there is a secondary market for the material, ranging from cosmetics to animal feed. The wastewater contribution to the BOD varies for each material. For example, the BOD in effluent water from a system that processes cherries may only be around 100 pounds per ton, where the BOD in effluent water from a system that processes cheese may be near 1,000 pounds per ton. Product loss translates to suspended solids. Suspended solids are measured by the dry weight of the solid material found in water. Some facilities get charged extra for a high level of suspended solids. Even if this charge doesn't apply, water with a high level of suspended solids generally also has a high BOD level, as the solids generally contribute to the oxygen demand. Food processing facilities often have fat, oil, and grease in their wastewater. If possible, these should be removed or prevented from entering the water. This will help avoid extra charges from a water utility provider. For some cities, piping water through the sewer network that is acidic or basic in nature can cause a lot of damage. Surcharges for pH level can be quite hefty and are meant to motivate customers to find a way to neutralize the pH in their wastewater. If a facility has high BOD, suspended solids, fat, oil, and grease, or pH levels, they should take samples from the wastewater at the end of each process so it is clear which processes are contributing the most to the undesired levels in wastewater. Since not all processes are created equally, it is recommended that a facility start with adjusting the processes that have been found to contribute the most to the skewed levels in wastewater. This can include making adjustments to prevent pieces of product from entering the wastewater stream when they aren't supposed to, but can also include changing processes themselves. If processes can be optimized or changed so that product loss is kept to a minimum, money can be saved from the product directly and also from the BOD sent through the wastewater. To correct these levels and bring them to an acceptable range, consider sweeping dry material to be disposed of before washing floors or equipment. Pre-treating water within a facility with a system, such as dissolved air flotation, to separately collect suspended solids and fats, oil, and grease before entering the sewer may be cost-effective in situations where facilities have already optimized processes and still incur high surcharges. Keep watching to learn more about what equipment and procedures food processors can adopt to reduce water use.